In this screencast, I'm going to give a brief introduction of implementing a queue in Python using what's called a circular array. Before we get started on that, just let me remind you that Python has an operator called the modulus operator, which is indicated by a %sign. And all that does is it takes two integers and returns the remainder, the integer remainder of the one integer divided by the other. So 7 modulo 3 returns 1 because 7 divided by 3 has a remainder of 1. And similarly, 8 divided by 3 has a remainder of 2, and 9 divided by 3 has a remainder of 0. So modular arithmetic has lots of applications. We're only going to need a very simple idea of this remainder result that will allow us to use an array and have it loop back on itself. And you'll see that in the next slide. So here's the first, let's just suppose we had a normal array. If we had a normal array and we started out and the queue had 3 elements in it, and this was the front and this is the rear. Now what the front represents here is the next, basically it references the element that's going to be the next one to be taken off the queue. And the rear indicates the slot where you're going to put the next element that's going to be enqueued. So if you go through these operations up here, if you enqueue a D, that'll put a D in this slot, and then enqueue an E, puts it there, and then if you dequeue, you'll take off the A. Okay, so front will now move down to here. Notice how rear is moved down to here. And then you take off the next element, which will be the B, and so now front will be referencing the C. So you'll have this, and then if you add F, right, remember we had D and E, and now we're going to add, rear is pointing to here, and now we're going to add F here, and we're going to be in this position. Okay, so you can see what happens in this simple example. As you enqueue and dequeue elements from the queue moves through the array. So if there's no mechanism to do something here, what you're going to have to do in order to be able to add another element is move all these elements back up to the beginning of the array so that you'll be able to add things. And you'll have to do that periodically. That prevents us from having constant time operations, because every once in a while the operation is basically going to take linear time in terms of the number of items that are currently in the queue. So what we need is a mechanism, if you will, so that the next item to be added is going to be added here. And that's where the modulus function comes in. So again, here's a little picture of what we want to do. What we want to be able to do is as the queue moves down into this area in the array, and we need to add another element, we're going to want to be able to zip back up here. And that's exactly what the modulus function will do. Here, constant time operations. So here's our new picture. Now, what we're going to need for our queue is we're going to need it to store the capacity. In this case, it's going to be 7, and we're going to be using modulus 7 as our way to move things from slot 6 and go to slot 0 to be the next place to be. And so we're going to have that capacity 7. We're going to have a front reference to the current item that's at the front of the queue that will be taken off first. And then we'll have a rear that points to the next slot to be entered to add an item where you'll enqueue the next item. And then we'll keep track with some variable that will keep track of the number in the queue. And I'll talk about why we need this in a second. Notice that this 3 is equal to rear minus front in most cases, most obvious cases. But anyway, let's continue. So what's going to happen here, again, is we move here when we add an element. Suppose we enqueue an element S, and we put it here. Then rear, right, will be set to 6 plus 1 mod 7. So we'll use the modulus function, and rear will be set to 0. And that's exactly what we want. So we'll keep track of doing that, and as the queue moves around this circular array, eventually the same thing will happen with front. Front will be here. This would be the front of our array. And then when we take something off, we'll move front out of here, the entry that's in this slot out. And then we have to increment front. And now it'll be 6 plus 1 mod 7. And front will then point to the next one. So that's the basic idea. I encourage you, students in my class, when you implement this, there are lots of different ways to do this, but I think the simplest way to understand what's going on is to have front point to the next element that's going to come off the queue, and rear point to the next position that you're going to put an element into the queue. And then you're going to want to have this extra numbing queue variable here that represents how many things are in the queue, because it turns out that we could try to use rear minus front to give us the number in the queue, but that turns out to have a difficulty distinguishing. You get the same answer when the queue is full as when it's empty. There are lots of different variations on this approach, but all I want you to get for, if you're in my class, is just this basic idea of using modular arithmetic to make the array circular.